Hello, this is your embedded ethics team. In this video, we will be discussing the AI alignment problem and go over two ways in which these problems are instantiated: reward hacking and negative side effects. After watching this mini lecture, you should be better prepared to answer problem 5 in the homework assignment. In this video, we'll define the AI alignment problem and go over two problems of AI alignment: reward hacking and negative side effects. We'll discuss these two problems and give some examples to help you identify them in the future. We'll also discuss the ethical implications of the AI alignment problem. Let's begin by talking about the AI alignment problem. The goal of AI alignment is to ensure that AI is properly aligned with human interests. AI misalignment occurs when an AI system is not able to achieve this. So, how do we define what alignment looks like? The first approach could be the agent does what I instruct it to do. It's simple. I give it a set of instructions and they follow it. But in reality, it is more complicated. Think about large models like large language models. It's not possible for us to take such a literal approach because there are so many parameters, contingencies, possibilities that we cannot give an instruction for all of them. This approach also runs into issues of reward hacking, which we'll talk about later in this video. Then, what about if the agent does what I intended to do? Suppose our development in AI is advanced enough for our models to understand the intentions behind our instructions. Say they grasp our human language, our cultures and practices. That sounds convincing. But again, we run into a problem. What if our intentions are irrational, misinformed? Should we still permit these models to operate according to our intentions? Okay, then let's say we want our agent to do what I want it to do if I were rational and informed. This way, we avoid lapses in judgment or errors from limited information. But this doesn't prevent us from wanting unethical or harmful things. Depending on our notion of rationality, which we won't get into here, and however informed we are, we can still arrive at desires that seem to be nevertheless morally reprehensible. Now, we finally arrive at the values approach. We design our A models to do what it morally ought to do, as defined by the individual or our broader society. Values indicate our judgment of what's good or bad and should be morally praised or reprehended. With a values-based approach, we can avoid all the difficulties we encountered with our previous conceptions of alignment. Additionally, we can think beyond the simple calculation of maximizing good and think about how our AI models can promote our notions of justice and rights. Importantly, though the values-based approach is not the end-all be-all, there can be many criticisms of the values-based approach. Similarly to how we walk through the other definitions of alignment, try to think about what can be some potential pushback against the values-based approach. How we decide which values to align with our AI models can be a bit tricky, and there is no consensus of which approach is best. Values are often specific to certain use cases and communities, so determining which values to prioritize often requires being sensitive to various cultural norms and values that your users may hold. Here, we'll share 3 possible frameworks rooted in philosophy and ethics you could draw on to better align AI models with values. The first principle is selecting values that are aligned with global public morality and previously codified human rights. Even though which values are important can vary among different communities, there are certain principles of justice that are supported by the majority of people. For example, basic human rights, such as the belief that all individuals should be given food, water, education, and protection from physical violence. Oftentimes, these have already been implemented into regulations by government organizations. The second is choosing values behind a veil of ignorance. The veil of ignorance is a thought experiment introduced by the philosopher John Rawls that asks people to consider a device that prevents them from knowing their own particular moral beliefs or the position they will occupy in society. So using the veil of ignorance, we might ask, what principles would people choose to regulate an AI system if they did not know who they were or what belief system they ascribe to? In other words, what principles or values might people select if they did not know for certain how the AI system would impact them? This principle assumes that people are risk-averse. Finally, the third principle is using social choice theory to combine different viewpoints to ultimately inform the alignment of an AI model. One way of doing this is through using democratic processes such as voting, discussion, and civic engagement to arrive at values. The other is by combining individual preferences into a single ranking. And again, these are not the only frameworks that would be appropriate to align an AI model with values, but they should give you a starting point. Now, let's take a look at those three principles in practice to help make those definitions a bit more concrete. Consider self-driving cars. If we are aligning values with the global public morality and human rights framework, we might consider existing regulations set by government entities. For example, the state of California Department of Motor Vehicles has a set of standards defining specific terms related to autonomous vehicles, requirements for testing permits, and requirements for test drivers. If we are selecting values using Rawls' veil of ignorance thought experiment, we might consider who's at greatest risk to prioritize the least well off. For example, pedestrians with darker skin might be more likely to get hit by a self-driving car than white pedestrians. So maybe this informs the values we select for how to test AI models in the real world. Finally, if we are using the social choice theory, we might involve different stakeholders in collectively determining how research, deployment, and oversight of autonomous vehicles is conducted. The alignment problem has important implications for real-life society. AI systems that are misaligned with their users and society's goals can cause significant harm. Let's look at some more examples. The first is Tay. Tay was a Microsoft AI chatbot launched on Twitter in March of 2016. In less than a day, it was taken down because it was generating tweets and replies that were considered racist and sexist. The bot's behavior wasn't necessarily due to a programming error. Instead, it was because the developers had not given the bot an understanding of appropriate human behavior. In the absence of that, the bot began to mimic the harmful behavior it saw among other Twitter users. We also see AI misalignment in medical applications of AI. For example, one algorithm used in the US to identify patients who might need additional care uses cost as a measure of healthcare need. However, because of unequal access to healthcare, typically less money is spent on care for Black patients compared to white patients. Thus, this leads the algorithm to prioritize white patients over sicker Black patients. As another example in this space, during the height of the COVID-19 pandemic, Facebook tried to promote vaccine-related content from government agencies to encourage people to get vaccinated. Potentially, the intended values here align with society's goals to stop the spread of the disease by getting more people vaccinated. Yet, these posts from official sources ended up being flooded with critical comments, including misinformation. And as posts with anti-vaccine comments became more visible to Facebook users, it may have undermined vaccine uptake. So recall in the mountain car assignment, you learned about safe exploration and reinforcement learning as one example of a problem in AI safety. Two other problems in AI safety, which are also examples of the AI alignment problem, are reward hacking and negative side effects. While these relate to AI safety and reinforcement learning, they are also relevant to other types of AI algorithms, such as large language models, evolutionary algorithms, and genetic algorithms. So in this video, we'll talk about them broadly rather than a specific type of algorithm. Let's begin by discussing reward hacking. Reward hacking occurs when an agent games its reward function. By doing this, the agent discovers a clever or easy solution that still formally satisfies the qualifications to acquire rewards and is able to maximize the rewards it receives. However, the solution they've discovered might not align with the spirit of the designer's intent. In other words, the agent optimizes the formal objective function but doesn't learn the outcome intended by the programmer or designer. For example, if we reward a cleaning robot for picking up messes, one way in which it might game its reward function is by hiding messes behind furniture or under the rug. Another way is by bringing in more trash and starting over once it's done to keep receiving the rewards. Let's consider two examples of reward hacking. In the first, a reinforcement learning agent that was designed to move a block to a certain position on the table learned to move the table rather than the block. In the second, ChatGPT made up fake cases related to a prompt when it was asked to deliver cases by a lawyer. Reward hacking arises from misspecified rewards. When important aspects of the reward have been left out in the design process, leading to poor agent behavior. One way to mitigate reward hacking is to anticipate and penalize a possible misbehavior in advance. But some things will be missed by human error. Addressing these limitations is still an open problem in AI research. Now we'll discuss negative side effects. Negative side effects arise when an agent's behavior while pursuing its goals ends up conflicting with broader societal values. Going back to the example of a cleaning robot, the robot might knock over a vase or push people and pets out of the way because it can clean faster by doing so. Some examples of negative side effects include an autonomous agent that splashes water on nearby pedestrians as it rolls by, or an AI system that completely displaces workers in a particular industry. Negative side effects occur because the agent's model and objective function focus on some aspects of the environment over others. This can happen either because of misalignment, distributional shifts, or the agent having incomplete knowledge. Misaligned systems are more likely to produce negative side effects because they are not aligned with users' intentions and goals. However, negative side effects can occur even in contexts where the agent optimizes values that align with users' objectives. For example, if an AI system is deployed in an environment that is different from the one it was tested in and does not have enough information about how to respond to a new scenario, negative side effects may occur.